welcome to Math Advice. In this video, let me see an example under odd and even functions in Fourier series. For that, let me take an example. Expand f of x is equal to x product pi square minus x square over 12 as a Fourier series in an open interval minus pi comma pi. So here we have to find the Fourier series representation of the given function f of x in an open interval minus pi comma pi. Before, let me enter into the problem. So we have a short look over the formulas that we are going to use in the given problem. So first very important one is Bernoulli's formula. So whenever you are having the product of two functions in an integration, to evaluate the integration we make use of this formula, that is integral uv dx is equal to u v1 minus u dash v2 plus u double dash v3 minus etc. Here both u and v are functions of x. Here u dash, u double dash etc. are successive derivatives of u, whereas v1, v2, v3 are successive integrals of v. Here u dash is nothing but du by dx, that is you have to differentiate u with respect to once with respect to x, right? D square u by dx square is your u double dash, that is differentiating u with respect to x twice, like that. Next v1 is nothing but integral v dx, that is you have to integrate v once with respect to x. v2 is nothing but you have to integrate v twice with respect to x. Instead of doing that, already we have to integrate that once. So you have to integrate v1 once again, that is your v2, isn't it? Next v3 is you have to integrate v thrice with respect to x. Already we have integrated v two times with respect to x, right? So here you have to integrate v2 once again with respect to x, that is here v3, etc. So u dash, u double dash, u triple dash are successive derivatives of u, whereas v1, v2, v3 are successive integrals of v. And the basic formulas of integration and differentiation, as you know already, that is integral x bar n dx is equal to x bar n plus 1 divided by n plus 1, and d by dx of x bar n is equal to nx power n minus 1, and integral sin nx dx is equal to minus cos nx divided by n, and integral cos nx dx is equal to sin nx divided by n. Also, should know the values of cos 0. The value of cos 0 is 1, whereas the value of cos n pi is minus 1 whole power n. Whereas the value of sin 0 is 0 and sin n pi is 0, where n is an integer. Here we have to discuss about only integer. So the values of sin n pi we have to take as 0. And the important points you should remember, that is, whenever the integral is from minus a to f of x dx, we can immediately write this as twice integral from 0 to a. That is, integral from minus a to a can be rewritten as twice integral from 0 to f of x dx whenever f of x is an even function. Suppose if f of x is an odd function, you can immediately write the integral value as 0 if f of x is an odd function. Next, product of even and even function gives you an even function, and product of odd and even function gives you an odd function, and product of even and odd function gives you an odd function, and odd function product gives you even function. So with this short introduction, let me now move into the problem. So here it is given that f of x is equal to x product pi square minus x square divided by 12, that is defined in an open interval minus pi comma pi. As I told you already, the case of odd and even function arise only for the intervals of type minus pi to pi and minus L to L. So whenever you write the function, you have to write the function along with the interval, that is very must. Okay, don't write in the solution part, don't write the function alone. Okay, write the function along with the interval, that is must. So based on the interval alone, we have to decide which type of Fourier series we are going to take and to represent the given function. Okay, so the case of odd and even functions arise only for the two intervals of type minus pi comma pi and minus L comma L, and the case of odd and even function doesn't arise for the intervals of type 0, 2 pi and 0, 2l. So only for these two intervals alone we are having the case of odd and even functions. Now the given function is defined at the interval minus pi, pi. For more details, the link is given in the description box. Refer the link for more details. So here the function is given in the open interval minus pi, pi. So how we are going to find whether it is an odd or even? As you know already, you have to replace the given function x by minus x. If you replace x by minus x, what happens? This is your f of x, that is equal to x product pi square minus x square divided by 2, 12. So here we have, in these two places we have x. Just replace x by minus x pi square minus x the whole square whole divided by 12. That is equal to minus x pi square minus x square. Sorry, I have to write here. Isn't it? Minus x square. Minus x square is nothing but plus x square. Isn't it? Whole divided by 12. What it is? It is your f of x. What is your f of x? This is your f of x. Isn't it? This is your f of x. That is x product pi square minus x square divided by 12 is your f of x. So this is nothing but minus of f of x. So f of minus x is equal to minus f of x. Isn't it? Which means what? The given function, therefore the given function f of x is odd function defined in an interval minus pi, pi. If it is an odd function, what is the conclusion? Immediately we can write the values of both a0 and an is equal to 0. Okay. So and just list out the formula table in pi form. So in 0 to 2 pi you just leave it. So here we have the problem under minus pi, pi. Under this we have three cases. If it is even, we make use of these formulas to calculate the values of a0, an and bn. For odd, we make use of these formulas. Here, neither even nor odd means we make use of these formulas. So here, we are having the case of odd function. So for that, we make use of this formula. Okay. So here we have only bn term alone. So the required Fourier series B, required Fourier series B of the form f of x is equal to, does it have a0 and also an. So you have only sigma n varies from 1 to infinity bn sin nx. You take this as equation number 1. So the formula we have used to calculate the value of bn is equal to 2 by pi integral from 0 to pi f of x sin nx dx. So just replace f of x by the given function. So 2 by pi integral 0 to pi, the given function is x product pi square minus x square over 12 sin nx dx. Here 6 2s are 12. So you take 6 outside of the integration. So 1 over 6 pi integral 0 to pi x product pi square minus x square sin nx dx. What I am going to do is, I am just take the 6 inside the square bracket. Okay. The next step, that is equal to 1 over 6 pi integral from 0 to pi. If you take x inside, what you get? Pi square x minus x cube sin nx dx. So I am going to split this integral into 2, or you can, what I am going to do is, I am going to split this integral into 2. That is 1 divided by 6 pi integral 0 to pi square x sin nx dx as one integral minus 1 over 6 pi integral 0 to pi x cube sin nx dx as the other integral. So look at here, pi square, here you have pi, so one of the pi being cancelled, So here you have pi divided by 6, isn't it? Pi by 6 integral from 0 to pi x sine nx dx minus 1 divided by 6 pi integral from 0 to pi x cube sine nx dx. So this is your Bn, isn't it? So if you are very well versed, this is the product of two functions inside the integration. So here we make use of Bernoulli's formula to evaluate this integral and for this integral. So if you are very well versed about the formulas of Bernoulli's formula, that means you can directly substitute the formula and you have to calculate the value of Bn. To simplify this, what I am going to do is, you have to take the first integral as I1 and second integral as I2 and you take this as equation number A. Now I am going to evaluate these two integrals separately and substitute in equation A gives me the value of Bn. So to simplify the calculation, I am going to do like this. Next, what is my I1 first integral, isn't it? So I1 is pi by 6 integral from 0 to pi x sine nx dx. This is your first integral. Here you have to take the first one as u and second one as v. So you know the formula, integral uv dx is equal to uv1 minus u dash v2. You have up to two terms for this function because here you have u as x. The first derivative you get 1, whereas the second derivative it becomes 0. So if you apply Bernoulli's formula, you have only these two terms. So for that first you write what is your u? U is x, u dash is 1, isn't it? U double dash 0. So next v1, v2 we calculate. v1 is nothing but integral v, that is integral sine nx dx. Integral sine nx is minus cos nx divided by n. This is your v1. Next v2 is, you have to integrate this v1 with respect to x. So minus 1 by n is constant. Integrating cos nx you get sin nx divided by n. Already you have n in the denominator, so that is n square, isn't it? So substitute in the formula, that is pi by 6 u v1. U is nothing but x. v1 is minus cos nx divided by n minus u dash is 1. v2 is minus sin nx divided by n square with the limit from 0 to pi, that is equal to pi over 6. So let me simplify the symbols. Minus and minus here becomes plus. Here you have minus, so take it to the front. Minus x cos nx divided by n plus sin nx divided by n square with the limit from 0 to pi. Let me substitute the limit, upper limit first and then lower limit. Okay, upper limit minus lower limit. So bracket is must, that's why I show you how you put the bracket, okay, for both upper limits and lower limits. Okay, so first you just replace the values of x by pi. If you replace the value of x by pi, what happens? Minus pi cos n pi. You know the value of cos n pi, that is minus 1 whole power n divided by n plus. If you replace in the second term x by pi, what happens? Sin n pi, that is 0. 0 divided by n square, that is 0. So no need to write it, you just put 0. Okay, minus. Coming to the lower limit, replace x by 0. If you replace this x by 0, what happens? 0 into anything? 0. So first term becomes 0. Coming to the second term, sin 0. You know the value of sin 0, that is also 0. So you have the first term alone, that is equal to pi by 6 minus pi minus 1 whole power n divided by n. So that is equal to minus pi square product minus 1 whole power n divided by 6n. This is your I1. Okay, we calculate the first integral. So we calculate this first integral value. So the first integral value we calculated. What we do next? We calculate the value of second integral and subtracting I1 minus I2 gives you the value of Bn. Now, let me calculate the value of I2. That is I2. What is your second integral? 1 divided by 6 pi. That is from integral from 0 to pi x cube sine nx dx. So here you take the first one as u and the second one as v. As usual, you apply the Bernoulli's formula. So you know the Bernoulli's formula, integral u v dx. That is u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4. Here x is of power 3, so you have up to u triple dash v4. The next derivative becomes 0, so you have to stop up to this. So to evaluate this integral, we can make use of the Bernoulli's formula. So it has 4 terms. Okay, so you calculate u dash, u double dash and u triple dash. So now, what is your u dash? So u is x cube. What is your u dash? 3x square, and u double dash 6x, and u triple dash is 6, isn't it? Next, here v is sine nx. v1 is integral sine nx dx. Integrating sine nx, you get minus cos nx divided by n, and v2 is nothing but minus. You have to integrate v1 once again with respect to x. So here v1 is minus cos nx by n. So here minus 1 divided by n is constant. Integrating cos nx, you get sin nx, isn't it? So sin nx divided by n square. And v3 is nothing but integral v2, okay, dx. That is, you have to integrate v2 once again with respect to x. We are integration, we have minus sin nx divided by n square dx. So integrating sin nx, you get here minus 1 by n square is constant. Integrating sin nx, you get minus cos nx. Already you have minus here, so that becomes plus cos nx divided by n square. Already you have n square, so divided by n is nothing, becomes n cube. Okay, so cos nx divided by n cube. So let me substitute in the formula. So here I2, which is equal to 1 divided by 6 pi uv1. U is nothing but x cube minus cos nx divided by n minus 3x square uv1 minus u dash v2. v2 is nothing but minus sin nx divided by n square plus u double dash, that is 6x. v3 is nothing but cos nx divided by n cube minus u triple dash, that is 6. v4 is sin nx divided by n power 4 with the limit from 0 to pi. So here we calculate up to v3. So if you need, you calculate v4. Okay, so that is your v4 is cos nx divided by n cube dx. That is nothing but integrating cos nx, you get sin nx divided by n. Already you have n cube in the denominator, so that becomes n power 4. Listen, these steps are not necessary. Okay, so these steps are not necessary. If you are very well versed about the Bernoulli's formula, you can evaluate after this step. Okay, after this step, you can write this step. Okay, so if you are a beginner, you can list out the values of u and v, and you have to differentiate u and you integrate v and put it in the formula like this and substituting the limit. Okay, so after work out some of the problems, you will be very well versed about the concept of Bernoulli's formula. So whenever you see the product of functions inside the integral, you can directly write down like this. Okay. Next, let me simplify the symbols. 1 divided by 6 pi. Here you have minus, take it to the front. X cube cos nx divided by n. Here minus and minus becomes plus. 3x square sin nx divided by n square plus here you have only plus term, so 6x cos nx divided by n cube minus 6 sin nx divided by n power 4 with the limit from 0 to pi. So in these places we have x term, just mark this. So let me first substitute the upper limit 1 over 6 pi. So this bracket for upper, it's a whole bracket. So upper limit minus lower limit. So bracket is must. Okay. So next, if you replace x by pi, what happened? Your first term minus pi cube cos n pi. You know the value of cos pi n pi is minus 1 whole power n divided by n plus, coming to the second term, sin n pi value becomes 0, isn't it? So I am just put directly 0 plus, coming to the third term, 6 pi, because that is cosine term having the value for pi. Okay, cos n pi is minus 1 whole power n divided by n cube minus 6 times sin n pi, that is nothing but 0. Sin n pi value is 0, so the last term becomes 0. Coming to the lower limit, if you replace x by 0, what happens? 0 into anything 0, first term 0. Coming to the second term, x, product, x is in product. If you replace x by 0, second term 0. Coming to the third, that is also x in product. If you replace x by 0, that is 0. Minus, coming to the last term, sin 0. You know the value of sin 0, that is 0. So you have only two terms, that is minus pi cube minus 1 whole power n divided by n plus 6 pi minus 1 whole power n divided by n cube. So just take 6 pi inside. If you take 6 pi inside, what happens? If you take 6 pi inside, what happens? One of the pi being cancelled, right? So here, I'm just write it here, minus pi square minus 1 whole power n divided by, so 6n alone, isn't it? Next, for this term, 6 pi and 6 pi being cancelled, you have only plus minus 1 whole power n divided by n cube. So this is the value of I2 we calculated. So substitute both the values of I1 and I2 in equation A. What is your equation A? That gives you the value of Bn. That is, Bn is equal to I1 minus I2. Your I1 value is minus pi square minus 1 whole power n divided by 6n minus I2 value is minus pi square minus 1 whole power n divided by 6n plus minus 1 whole power n divided by n cube. What happens here? Minus and minus becomes plus, plus minus becomes minus. Here look at these terms. I am just writing once again. Minus pi square minus 1 whole power n divided by 6n plus pi square minus 1 whole power n divided by 6n and plus minus 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 1 whole power n divided by n cube. So both of them same in magnitude but opposite in sign. So first and second term being cancelled, you get the value of Bn as minus of minus 1 whole power n divided by n cube, or you can write this as minus 1 whole power n plus 1 divided by n cube. Both of them are same. Okay. Which of them you prefer? That's okay. Next, let me substitute in equation 1. What is the equation 1? So equation 1 becomes f of x equal to sigma n varies from 1 to infinity bn sin nx. So let me substitute the values of bn. Sigma n varies from 1 to infinity. What is your bn? So either I can write this as minus 1 whole power n plus 1 divided by n cube sin nx, or you can write your f of x as sigma n varies from 1 to infinity minus of minus 1 whole power n divided by n cube sin nx. Both are equivalent. Okay. So that's all. So this is the Fourier series representation of the given function f of x is equal to x product pi square minus x square divided by 12. Okay, this the Fourier series representation of the given function is this one. So after this, hope you got a clear idea about how to evaluate. The given function is in odd form. That is, given function is of odd type. in an interval minus pi comma pi. Thanks for watching. See you all again in my next video.